Greetings students and viewers at home. Welcome to Tcha YONGA YouTube channel, a channel where we try to relate science, maths and reality. And today we are in nature, and behind us is a car. And the reason a car is behind us because most of the youths out there usually have one of their ambition is to have a car. But what we never understand, we never want to know the science behind a car. And today I'm going to show you all the science which are involved in a car. And to start with, we'll start with the metal. Which metals are used to make cars? Metals which are used to make cars are steel and aluminium. But the commonly used is steel. Steel is an alloy. And an alloy is where you mix two metals or two elements to make another compound or substance. So steel is an alloy which is made up of iron and carbon. The other metal used to make cars is aluminium, and aluminium is the best because first it is stronger than steel, and also it is lighter. It's not a very heavy metal. That's the first thing we learn about a car. Also, if you can observe clearly, the car has been painted blue or gray. I'm not sure with the colors, but why is it painted? First, there's for the aesthetic value or aesthetic benefit, so that it can look good. But there's also the scientific importance why the car has been painted. Why it has been painted is to reduce rusting. We know that one method of preventing rusting is by painting. So when you paint a car or when you paint a metal, the metal doesn't get rust. So that's another science which is involved in a car. So anytime you want to buy a car, don't look at the color just because it looks good. Look at the color also because it will prevent the rusting process. And you remember the conditions necessary for rusting are oxygen and water. Let's move to the shape. Why does the car have this kind of shape? This kind of shape is referred to as a streamlined body shape. It's a shape which is similar to that of a fish. Why do cars have this kind of shape? Especially racing cars like Lamborghini and Ferrari. This kind of shape reduces friction, or what we refer to as drag or air resistance. When a car is moving, the air will cause a certain kind of resistance. So if a car has a block shape, the air resistance will be more. But if it has a streamlined shape, the air resistance is lowered and the car can move at a higher speed. That's why even aeroplanes are the best example to show that they have a streamlined shape. A jet, the shape of a jet is a streamlined shape, and what it does, it reduces friction. The other ways of reducing friction, also lubricating. When you lubricate a machine, you also reduce the rate of friction. So we have seen at color and the material used to make a car, and also why we paint a car. Now let's move to the door handle. We have here a door of the car. So there's a reason why the door is at this part but not at this part. This is because of what we refer to as moment. Moment is the turning effect of a force. So how do we calculate moment? This part of the car is the pivot. This part is the where we apply the force. This distance is the perpendicular distance from the pivot to the where you apply the force. So if you put the handle here, the moment will be low. So the farther away the handle from the pivot, the higher the moment. So you use less effort to open the door. That's why the door is not placed here. It's placed here so that you can increase the perpendicular distance from the moment. Let's move to, we have something here very important which we use to look at ourselves, and which reminds me that I didn't comb my hair today. Anyway, this kind of mirror is not the same mirror which we use at our home. The kind of mirror we use at our home is a plain mirror. But this kind of mirror is referred to as a curved mirror. And we have two types of curved mirrors. We have concave mirrors and we have convex mirrors. Which mirror do we prefer for making side mirrors? We prefer convex mirrors. Why do we prefer convex mirrors? Concave mirrors, they don't show, the images are not consistent. The image changes depending with the distance of the object from the mirror. Like if the distance is too much, the image will be inverted or upside down. It shows the image if it is upside down. So concave mirrors are not preferred for making side mirrors, because if the distance of the object is far away, it shows an inverted image. You can imagine when you are driving and then you see a car is upside down from your side mirror. That actually will even cause the accident. So the mirror preferred is convex mirror. Why do we prefer convex mirror? The image will not change even regardless of the distance of the object. Even if the object is 100 meters away, still the image will remain upright. Another thing, it also shows a wide view. It shows a wide view of your image. When you look at a side mirror, it can show you the whole road. You can see the cars from one side to the other side. So those are the two reasons why side mirrors are made of convex mirror. Remember, the other type of mirror is the concave mirror. The other type of mirror is the concave mirror. The something which makes this car to be important, or what makes its utility or to be utilized, is what usually enters through this part, what we refer to as fuel. The general name is a fuel. And we have different types of fuel which are usually used in cars. We have gasoline, also the other name is diesel. We also have petrol or propane. Its chemical formula is C3H8. And also in countries like Brazil, they use ethanol as a fuel. So how does this fuel help the car to move? The fuel usually undergoes in a process we refer to as combustion. So the fuel usually comes, those three fuels which I've named, that's propane. Propane, the other name is petrol. We have gasoline, the other name is diesel. And also some countries like Brazil, they use ethanol. So that fuel comes to this part where we have the engine. So usually in the engine, we have what we refer to as pistons. So when you ignite the car or when you start the car, you start the process of combustion, the fuel starts to burn. When it burns, it produces CO2, water, and energy. That energy, inside here, we have what we refer to as pistons. The pistons usually move up and down, up and down, up and down. As the pistons move up and down here, we have what we refer to as a crankshaft. The crankshaft starts to rotate. As it rotates, the car starts to move. So it's not a rocket science. Actually, that's a challenge to you students. Next time when you're presenting projects, I hope you will start presenting projects where a student has produced a car, because it's not a rocket science. It's just the fuel burns. When it burns, it makes the pistons to move up and down, and as the pistons move up and down, they make the crankshaft to rotate, and the crankshaft, as it rotates, the car moves. And that's the science behind it. So you need to know that when a fuel burns, it gives you carbon dioxide and water. There's another thing which happens. These fuels, usually they add some other additives so that they can be friendly to the engine. They can add nitrogen, they can add lead. So when these additives burn, they produce what we refer to as greenhouse gases. These gases are harmful to the environment because like some of the gas which are released are nitrogen 4 oxide, which is an acidic gas. And this gas, usually when it mixes with rain, it forms acidic rain. It forms acidic rain. So nowadays, modern cars, they have devised a way to reduce emission of these gases. How have they devised a way? Usually the exhaust pipes. If we go behind our car in the exhaust pipes, we'll see that the exhaust pipes, let's move swiftly and see what is behind here. There's a connection from the front part to this behind part. As there's burning, gases, some gas are released through this small pipe here. This is an exhaust pipe. Nowadays, this exhaust pipe is fixed with what we refer to as a catalytic converter. The catalytic converter, what it does, it converts those gases into less harmful gases. Like the nitrogen 4 oxide, NO2, will be converted to nitrogen gas. Nitrogen gas is an inert gas and it's an harmless gas. So whatever is emitted here is not harmful to the environment. So actually even our industries, that's what they should implement through their chimneys. Connect the chimney with something which can convert the gas into a less harmful gas. That's the only way to solve the problem of global warming. It's not a rocket science, it's something easier. If it can be done to a car, it can also be done to an industry. So I hope students, you are learning. Now if you're ambitious about a car, now you know, at least understand even the science inside the car, and automatically the car will come. We all usually say 4 cars so that you can have the 4 cars. Yeah, 4 cars so that you can have the 4 cars. Now we'll go and enter into the car and see what science is involved inside a car. I told you that how do you make the fuel to start the combustion. So how you make the fuel to start the combustion, you need to ignite the car, and you start the car. When you start the car, that's when the combustion process starts. And then now the pistons are moving up and down, and then we just move the car and it starts to rotate. So that's the first thing, how you ignite the car. Then you're always told to buckle up. Why are you always told to buckle up? You're always told areas when you're in a car, you need to buckle up. Why are you told to buckle up? In physics, we have what we refer to as inertia. What is inertia? Inertia is the resistance of any object to any change in its velocity. It's the resistance of any object, and us as human beings, we are an object because we are matter. And matter is anything which has mass and occupies space. So matter will try to resist any change. So when you're driving a car, you'll be in motion. But when you put an emergency brake, what will your body do? It will resist that change in its velocity. You are moving, but you have put a brake on the car. The car is the one which has stopped, but your body will resist that motion. So you'll go forward. So if you don't have the safety belt, some people usually even go past the windscreen. Some people go past the windscreen. It depends with the motion of the car. So that's inertia. You can be told to define inertia. It's the resistance of any object to change of its velocity. Or velocity is the motion or speed. And also here we have the speedometer, which usually tells you at what speed are you moving at. You see it's put in kilometer per hour. So if it's at here, it means your car is moving at 20 kilometers per hour. So it means in a distance of 20 kilometers, you'll cover it in 1 hour. So always when driving, to be safe, always buckle up because of inertia. Inertia can cause damage. The last science which we are going to look at, which is involved in a car, is the brake. And this brake, the principle which it uses is what referred to as the Pascal's principle. Pascal principle is found in physics topic under pressure. What does it state, Pascal's principle? It states that when you apply pressure to an enclosed liquid, the pressure is transmitted equally to other parts of the enclosed liquid. When you apply pressure, when you step on the brake, you are applying pressure. Inside this, there's a mechanism down here which has a fluid, and that fluid we refer it to as brake fluid. So when you apply this pressure here, the pressure will be transmitted equally to any part of this fluid, and it is enclosed. So the pressure will be applied to the tire there. When the pressure is applied there, the fluid flows, and when it gets to the pads, it makes them to spread like this, and then they attach themselves to the tire, and the tire stops, and then your vehicle stops immediately. So the brakes use what refers as the Pascal's principle. And what does it state? That pressure applied on an enclosed fluid is transmitted equally to other parts of the enclosed fluid. It's transmitted equally to other parts of the enclosed fluid. So, and that fluid, it has properties. We call it a brake fluid. Which properties should a brake fluid have? First, it should be incompressible. Incompressible. What do we mean by incompressible? It means it should not be compressed. When you apply pressure, it should not compress itself. It should just move with that pressure. Second thing, it should have a high boiling point and very low melting point. Why high melting point? Maybe why high boiling point? You might go to places like Garissa or Wajir where the temperature is too high. If it has a very low boiling point, your brake fluid will start turning into a gas. Then when you apply brakes, you think that the brakes is not working. But what has happened is that your brake fluid has turned into gaseous form. Another thing, it should also have a very low melting point. Why? If you go to European countries where the temperature is too low, or if you go to polar countries, the fluid will melt and freeze. So when you apply brakes, there's no mechanism, there's no Pascal principle which will be applied. So your car will not stop immediately. And those students are the science which are involved in a car. And it's good to be ambitious, but also it's also good to be ambitious of knowledge. And we have said this channel, please, I'm urging you to subscribe, because each and every day I'll be teaching you the science and maths and how they're connected with our reality. And I hope if this is one of my dream car, since I don't have one, but I hope I'll get one, this one. And we start the car and see you, and please subscribe to the YouTube